Hi there. Welcome to today's lesson. Today's lesson is about position and movement. Now we're going to learn how to do more than one movement in our lesson today, but let's start with some basics you already know. So to transform a shape, it means moving it from the original position to a new location or a new position. So the first thing you're going to learn is about reflecting. Reflecting is like this shape right here. So any shape, before reflecting it, the original shape will be called an object. But after we reflect it, it's called an image. After any movement or any transformation that happens to the original object, we will be calling it an image. Now, if I want you to reflect this shape on this coordinate grid, you need to know where the mirror line is. In this question, I already assigned the mirror line for you. So reflecting an object is exactly like looking in the mirror. You do not reflect it like moving it or translating it. No, reflecting means the points will be opposite from each other. So let's call this point A. And point B and point C. Okay? Now, if you take a look at where did each point get after we reflected it, all points will have the exact same distance from the mirror line. So in here, you can see that point C had only 2 squares or 2 centimeters away from the mirror line. So to draw it on this side, after reflecting, to draw the image, point C will also have to be 2 squares far from the mirror line. For point A, it's exactly on the mirror line, so I don't need to do any distance. For point B, it's also exactly 2 squares. I will just count 2 squares from the mirror line in the opposite direction and assign point B. Now I have the new location or new coordinates for point A, B, and C. All I have to do is link the sides together, and there I have my image after reflecting. Now for translation or movement of objects, let's take a look at this object. I have this triangle, we'll call it object X, Y, Z. And after reflecting it, after moving it or translating it, we'll have a new coordinates for each of X, Y, and Z. But notice that this is called an object, and after translating it or transforming it or moving it, we called it an image. Now, how did we find the image for this object? We cannot just translate any shape without some instructions. For this shape, the instructions were: move the shape 3 squares up and 2 squares left. Of course, your instructions could change, but they will always be move it squares up or down, right or left. For this question, the instructions were 3 squares up and 2 squares left. Of course, it does not matter which one we'll do first, because in both cases, we will end up at the same location. Now let's see, how did we move this shape into its new location? Let's start with X. We have to move 3 squares up. So I counted 1 square, 2, 3 squares up, and then I need 2 squares left. So I will do 1 square, 2 squares. Here will be the new coordinates for point A. Now for point B, this is x. Now for point y, let's do vice versa. Let's do 2 squares left and then 3 squares up. If I do 2 squares left, I will count 1, 2 squares. I'm here. I done the 2 squares left. Now I have to do the 3 squares up. So I will count 1, 2, 3. Here will be my new point y. Now the only point I need left is z or z. For point z, I'll need to go 3 squares up and 2 squares left. I will go 3 squares up, 1, 2, 3, and 2 squares left, 1, 2. Here I'll have square z. Of course, this sketching can be left on the original paper, or if you can draw them with a pencil and then erase them. But if you want to leave them out, it's fine. It shows your work and how you got to the new location for the image. Now the image, the object after transforming will be called an image. Here we have the new coordinates for x and for y and for z. All we have to do is link all of them together and we'll have the new image of this triangle. Now the third thing you're gonna learn is about rotation. Rotation is a little bit tricky for students, so I'm gonna try to make it as easy as possible. We have 2 ways, using a trace paper or not. You can choose whatever you want. There is no one way better than the other. For each object that we rotate, we need 2 information. First thing, we need to know where the center of rotation is. For this figure right here, for this object, the center of rotation is here. Of course, the question will assign the center of rotation always. The second thing you need to know is, are we rotating it counterclockwise or or clockwise? If we're rotating it clockwise, it means we are rotating it like the clock hand is moving. If we're rotating it counterclockwise, it means we are rotating the other direction against the clock hand. You will get a handle of it once we do more examples. Now for this rotation, we are rotating 180 degrees clockwise. Or we can say we are rotating half a turn. A turn is a circle, so half a turn is half a circle. Now, for our rotation, the first way I am going to use a tracing paper to show you exactly how you can do this. Tracing paper, or some people call it parchment paper. This is probably found in your kitchen. And of course, you can use clear paper that can be bought from the library. Now, for this question, I will draw our new object right here. And then we have the center of rotation that was assigned in the question. Now, for this question, you will look at your object and place your tracing paper exactly on top of your object, and you will put your pencil in the center of rotation. Now, the question wanted me to rotate it 180 clockwise. Clockwise is this direction, because clockwise is like the clock hand moves. Now, 180. First of all, let's just draw the axis of the y and the x-axis as well. This will make it easy for me to know when exactly to stop. I would rotate one time until both of my axes line up. This is just a 90-degree clockwise. I need to rotate another quarter turn to be at 180. If you look here, you will find that our object lined exactly with the image I already drew of the object. Of course, for you, the image will not be present, so you need to draw it. Let's do that one more time. This is my tracing paper. I put it on top of my object, and then I line over my object, I draw the axes, and I assign the center of rotation. Now I start rotating 180 degrees. It means I will just rotate once until the axes line up as you see here. This is only 90 degrees clockwise. I need to rotate one more time to be at 180. If you look at the new location of my object, the image here, it lines exactly with the image I draw. For you, you need to press slightly on your pen or pencil with a little bit of pressure to have your marks. As you see, of course, it may not be very clear, but for me, it is obvious that it was here. Now we're gonna take a combination of transformation. A combination of transformation is doing more than one transformation at once. Let's see how can we achieve that. Here on this diagram, it shows a triangle A. This is triangle A. Okay. What is wanted from me, first thing, they want me to reflect this triangle in the line y equals 4. Reflect on the line equals 4. A, reflect on the line y equals 4. So I need to do, this is my object, I need to do an image reflected on the line y equals 4. First of all, if you are following with me from your Cambridge book, this will be in your course book, page 159. This is a worked example in your book. Now, let's see how can we do this as simple as possible. First thing we need to do is assign line y equals 4. For this grid, this is the x-axis and this is the y-axis. For line y equals 4, when I am giving a line y equals 4, it will be perpendicular to the y-axis. This is called y equals 4. For another question, if he wants me to draw my triangle or reflect it on the line x equals 7, x equals 7 will be perpendicular to the x-axis, so it'll be vertical. But for y, it'll be horizontal, perpendicular to the y-axis. Now let's start plotting my new image. Reflecting is using a mirror line. This is my mirror line assigned from the question y equals 4. For reflecting, we said the only thing we have to do is count exact squares. So I will count this 1 square. So I will count also 1 square in the other direction. So this point will be here. Let's name them X, Y, Z. So point X, or the new coordinates for point X, will be here. I only counted this X is 1 square far from the mirror line, so I counted also 1 square in the other direction. For point Z or Z, it's also only 1 square, so I will count 1 square in the other direction. This is the new location for point Z. For point Y, well, you can plot Y first, or you can draw your line between X and Z like it is drawn here. Now I need Y. Y will not be here. Most students get confused and plot Y here and draw the triangle like this, but this is not a reflection, this is a translation. But to do reflection, you need to count how many squares. Y is 2 squares far from the mirror line. We need to count 2 squares in the other direction. So we'll count 1, 2. This is where the new Y coordinates. And then we will connect our 3 dots, and now you can see I have object A and I have the image of object A after reflecting. You don't need to use tracing paper for this, you just need to count squares. Honestly, this is the easiest way I could find for you guys. Now, if I am asked to translate triangle A, 3 squares right and 2 squares down, let's draw another square, another triangle. So it's easier for us to translate it. And will be more clear. This is triangle A. Triangle A need to be translated. Two squares to the right and 3 squares down. This is a little bit different from your book. Your book says 2 squares down and 3 squares right. We're gonna mix it a little bit. We're gonna do 2 squares right. So this is point X, Y, and Z. Now for this to be very clear for you, we are going to do counting of the squares as well as we did in the previous introduction. Here, this was translating of this object into this image, 3 squares up and 2 squares left, and we counted the squares. We're going to do the same in this triangle. We're going to translate it 2 squares right. So for each one of these points, we're going to count 2 squares to the right and 3 squares down. So let's start with the down squares first. For Y, we're going to do 3 squares down, which is 1, 2, 3. And then from here, we're going to do 2 squares right. This is the new location or the new coordinates for dot Y. Now for X, we're going to do the same. 3 squares down, or let's do 2 squares right and 3 squares down. This is X, the new coordinates for dot X. Now for Z, we're going to do 2 squares right and 3 squares down. Here is where Z will be. Now all we have to do is connect the dots. X to Y, Y to Z. This is a little crooked. And X to Z. Now you can see that this is object A. This is the image of object A after translating it 2 squares to the right and 3 squares down. You only need to count squares in reflecting and translation. It gets a little bit tricky in rotation. Let's use, we are going to rotate a triangle. I'm going to draw my triangle. First, let's draw the grid. Here I have my grid. This is 1, 2, 3, 4, 5, 6, 7, 8. Of course, in most questions, the grid is already drawn for you. Now let's draw triangle A. This is triangle A. Now I need to rotate triangle A 180 degrees about the point 4, 5. I have coordinates for the center of rotation. It's 4, 5. This is my center of rotation. 4, 5. Let's do 4, 4 here. This is the center of rotation and this is my object. Now to rotate my object, let's do the tracing paper method. I will put my tracing paper over the object. It needs to cover the object and the center of rotation. I'll assign the center of rotation. I will draw my X and Y axis, and then I will draw my object. Now, to do my rotation, I usually like to make a hole at the center of rotation so I can rotate it easily. I needed to do 180 degrees clockwise, so I will only do 90 degrees first. This is 90 degrees. You can see we can count it as a turn because the grid, the X, Y, and Y axes are back to the normal positions. Now we're gonna continue because we want it at 180. This is the new location for my object. Now, how can I transform this into my paper, into my question paper? All you need to do is push a little bit more on your tracing paper because this tracing paper will not be given to your teacher. You just need to put a little bit of pressure into it, or you can make a hole. As you see, I hope it's clear for you. Here is my point, here's my second point, here's my third. All I have to do now is line them or connect them. Of course, you will need to use your ruler for connecting. What if I had a combination of transformation? What if the question wanted me to rotate clockwise and then reflect? How will this look? First of all, let's do the rotation. Rotate triangle A 90 degrees clockwise about the center of rotation 1, 5. Where is the center of rotation 1, 5? Let's assign that. This is 1, 5. So I need to rotate this triangle. I need to rotate this triangle 90 degrees. About the point 1, 5. This is my tracing paper. Now, this is my triangle. I will assign it on my tracing paper and assign the center of rotation. Here are my axes. Now, how I'm going to do this is I am going to take my pencil and put it in the center of the rotation. Now, all I have to do is rotate 90 degrees clockwise. Clockwise means this way because like the hand on the clock. Just 90 degrees. Of course, 90 degrees means you rotate one time until the X and Y axes line up together. Again, this is only 90 degrees. Now, all I have to do is assign my new triangle. It's here and here and here. Of course, you can do something else if you want to make it more clear or more clean on your paper, on your question paper. You can just take the coordinates. So it'll be on 1, 3. So you remove the tracing paper. On 1, 3, you can plot the first coordinates. The second one will be on the origin or center of rotation, and the third one will be on 3, 5 over here. Of course, you might say that it was supposed to be here. Yes, but because I didn't draw it with a ruler, it's supposed to be more clear. So my new triangle after rotation is here. Then I have to do the second request or the second instruction, which is reflection in the line x equals 2. So x equals 2, or let's do x equals 3. X equals 3, we said to assign it, it will be perpendicular to the x-axis. It'll be a vertical line. That's not very clear for you. There. To do my reflection, all we have to do is count squares. Now, this point is exactly on the line. This point will be 1, 2. So I need to count 1, 2. It's right here. And for this point, it's 1, 2. I need to count 1, 2. It's right here. So I have my 3 points. All I have to do is line them or connect them together. And there you have it. This object right here has been reflected and that has been rotated. This is from the previous question. So this triangle, we rotated it 90 degrees clockwise and then we reflected it about the line x equals 3. And that is it. I hope this was helpful. I hope to see you next time. If you have any questions, please leave them down below.